Okay, so we ended on slide number 7 with our GPE, our gravitational potential energy. And so mass and height, like David said, those are our two variables that are going to affect an object's gravitational potential energy. So GPE, that abbreviation, is what we're going to use a lot. And so with our GPE, mass and height, and we also said, okay, potential energy is energy of position. Sometimes it can be like stored up energy, or excuse me, it's energy that's stored up, whether it's position or whether it's just like holding it there waiting. So GPE is energy of position, right? You change its location, you give it more height, meaning that you allow gravity to act on it more, right? We're going to move on and talk about our second form, which is elastic potential energy. Now, we did not have this as a non-contact force, right? Elastic potential is not non-contact. Gravitational was, but this is kind of a new one. So elastic potential, what do you think it's going to be dealing with? Braden? Yeah, elastic stuff that has elasticity. So a piece of paper is not elastic, right? Sometimes things will seem like, okay, so like if you have a stick, you can bend it for so long, but then it's going to break, right? So up to a certain point, it might be a little elasticity or show elasticity, but not everything is going to be elastic. If I have a pop can and I smash it, it's not going to bounce back, right? Once I smash it, it's smashed. So that doesn't have elasticity. So, you know, just kind of think about, can you stretch it a certain amount and then it will go back to the way it was, right? That's kind of what we're talking about. So it's a type of potential energy, an elastic object. So again, that's pretty generic. Braden, why don't you move up here? Move up here. Up here. I'm tired of you looking around and you and Anna spending too much time looking at each other and giggling and distracting other people. Okay? So, this is dealing with any object that is dealing with having the property of being elastic. So, it's kind of generic. I can't say, oh, it's only rubber bands or it's only this or it's only that. Like a lot of things kind of can show this. So, just have to think, does it kind of go back to its original position if you let go, right? And that will help you kind of realize, oh, it's stretched or it's not stretched, or, you know, it has that property. So the strength of the elastic potential energy is based on the amount of stretch or compression that an object undergoes. So you only have like 10 vocab words. 5 of them are our 5 types of potential energy. 2 of them, well, maybe just one, maybe just the compression is here. So show me with your hands what it might look like to compress something. What do you think it'd look like? Good, I'm seeing you guys go bringing your hands together like this. What would it look like to stretch? Right? Good, so you already know what those things are. So keep that in mind as you're thinking of these objects, right? If you change the amount that you squish or press something together, that can change the elastic potential. If you change the amount that you stretch something, that can change. So it can happen both directions, whether you're, compressing it or whether you're stretching it. Now, obviously, a rubber band, I'm going to stretch, right? Because none of you were worried when I just had it like this. I'm like, ooh, gonna get you. None of you were worried. But yesterday when I had it stretched, some of you were a little bit flinchy, right? Like, ooh, is she gonna actually let it fly? Maybe, maybe not, right? I have stretched it, giving it potential energy to move, right? Because as soon as I let go, it's going to try to go back to the original position, right? So if I have given it a change, stretched it, has potential to return to normal, right? If you think of a spring that I push together, if I push that spring, what's the spring want to do? Wants to go back out, wants to go back to the original. So all of these things, the original is like when nothing is being done to it. When that spring is just sitting there, it's not doing anything. But if I compress it together, if I let it's gonna jump back.
So, like, is a spring considered elastic?
Yeah, it can have elastic potential energy, for sure. Yep.
So if you start to spring down like enough and leave it there, won't it just like stay there?
Like change so it won't want to? Not typically. Like if you would like twist it or like change the springiness of it, then yes, which I don't know if that's a real word or not, but you guys get what I'm saying. Like if you would mess up the shape of the spring, because that coil is what's causing that to happen, right? So if you change that, then that could cause that to happen, I guess. So it can happen whether you compress it and it wants to go back to normal, or like my rubber band, if I stretch it and it wants to go back to normal. It's all about causing a change, making it different from its normal positioning. And so everything just wants to go back to the way it was. And so elastic potential energy is a type of energy that is dealing with positioning, just like our GPE was. I've changed my rubber band's position. Now it has elastic potential energy to want to return to the original. Okay? Just like if I give an object more height, I've given it GPE to want to allow gravity to act on it and fall. All right. So, give me some examples besides a rubber band and maybe a spring that might have elastic potential energy. Give me some things. Eric?
The string on the bow and arrow.
Very nice. Yeah, the string on the bow and arrow. Oh, sorry, I thought your hand was up. Yeah, could, right? Because it can compress and stretch, compress and stretch.
A hair tie?
Definitely, yes.
One of them, like, things that you put on your foot, like a...
Like the exercise band?
Yeah.
Yeah, definitely. Go
Car
over.
shocks.
What is it?
Car shocks.
Absolutely. Very good. Marcus.
Headband.
Yep, headband.
Air.
Okay, so it could expand and contract. So I get what you're saying, but it doesn't work the exact same way. That's how tightly packed molecules are. Okay, so not exactly the same way. I get what you're saying though. Eric?
The things that are like in the remote where you put the batteries.
Oh, to hold the batteries tight.
Yeah.
A spring, sure,
Oh.
yeah. But it's an example of a spring, so good. Awesome, very good ideas. So springs, which you guys got, bow and arrow, yes. Bungee cords, that's kind of the purpose, right? Kind of like your exercise band will work the same way. And then like a trampoline, for sure, like the actual netting, that's why it pushes you back up, because it wants to return to that normal. You've stretched it and it wants to go back. The picture back here, yes, pole vault, thank you. I was thinking javelin, I'm like, that's not right. Whew, it's been a long day. So a pole vault pole, right? It's going to bend, and guess what? It has so much elastic potential energy that it helps fling you, if you're the pole vaulter, over the bar and like raises you up high, right? So you run with it and you bend it, giving it potential energy, that elastic potential, and then that wants to return back to that straight, the perfectly vertical, straight pole instead of the curved pole, okay? Okay, so let's take a look at this. When does an object have the most elastic potential? So the key here, there's kind of like a set rule for this. When you have given it the most stretch, if you've pulled it as far as possible. So here's a little more, here's a little more. I really don't want to go any farther because it feels pretty tight, right? So this has more elastic potential than it does when it's just right here. The more I stretch it, the more elastic potential it has. The more potential it has to return to normal. Yes?
What's that thing about that guy's little...
It's like an exercise thing where it's kind of like a little workout thing. It's kind of, they were more popular like years ago. Here is the other way, because stretch isn't the only way that elastic potential can happen. Compression, so the more you push or jam something together. the more elastic potential you're gonna have. So if you take that spring and I push it together, the more I push it, the more it wants to bounce back to its normal positioning. Yes?
Please, Mom.
Dang it, I guess. You have to fill in the notes.
No, I won.
Thank you for always reminding me to
Wait,
get out of
she
the way.
set you up here for a reason.
Mm-hmm.
Told me not to fill the notes when I'm done.
I didn't say how scripture.
Instructions are everybody turns to teach you. All right, so those are the two ways that we can have the most elastic potential. Give it more stretch or give it more squish, right? More compression. All right, so let's think of it like this. The more that you stretch or compress an object, the farther you're moving it away from its normal or original position. What?
Like your muscles, like like the muscles in your legs.
Yeah. So the individual little muscle fibers, they do stretch. Each little one, right? That's why, like, when you flex, you feel that change in your muscles because they actually are compressing. The muscle fibers do stretch and compress. Yes.
Hydraulics.
The same general motion, but it's not dealing with elastic. You're definitely thinking of the right movement, but it's not dealing with an elastic material. Yes.
Jump rope.
No.
Depends on what it's made of. Rope, probably not so much. A rubbery one, yes. Kind of like a yoga band or an exercise band. Let's not do that. Okay. So, when it is very far from its original, so we all agree this is the original. I'm not doing anything to it. This is just the way it is. When I move it very far from that normal or original, that's when it has high potential to return back to normal. If I just move it a little, it has some elastic potential energy, but not as much as when I move it a lot. If I'm just a little bit away, I have a little. But if I move it a lot, I have high potential to come back to normal. Okay? So the less stretch or compression, the closer to normal, meaning I have low potential energy to move because it's already close to normal, meaning low PE or potential energy. So you can think of it as how close is it to its normal and original position. If it's really far away, then you have high potential to get back to normal. If you have not very far away from your original, then it's low potential because you don't have far to move to get back to normal. So if we look at this, we have one extreme to the other. Raise your hand if you think that the one on the left is closest to the original position. Okay? Raise your hand if you think this is closest to the original position.
You guys.
Okay. So if this is closest to the original position, then this means it's going to have low potential energy because it's already pretty normal. This one is the farthest from its original position, so this makes it high potential to move back to this. So just kind of think about it logically. What would it normally be doing? If it's doing it, then it has low potential to change because something would have to make it change. All right? If it has high potential to change, it's because it wants to get back here very quickly. Okay, so let's look at compression. I don't have a good spring. I've looked for one. I don't have a good one. So if this is the free length meaning this is where it would normally be found. And then I compress it to this, right? This is the normal original. This is the compressed. Which one of these is going to be the one that has high potential to change? Raise your hand if you think this side is the one that has high potential to change. Raise your hand if you think this one. Oh, you guys are so good. You are. Very nice. I like it. Very good. Okay, so if we have this, it's important because this tells you this is the original and normal. So the block is going to push into the spring over here to compress it. All right? So which one is gonna have the most elastic potential? The most potential to move? Or which one's the farthest from normal? It's all the same way to think about it. Raise your hand if you think this has the most potential energy. Raise your hand if you think this side is showing the most elastic potential. Man, oh man, you guys are good.
Yeah, first grade.
You're talkative and distracted, but you have good brains in there. Okay, so the spring on the right has more compression, therefore more potential energy to spring back to get to the original. It's all about what's the original, what's the change. If it's changed, the more it's changed, the more it wants to get back to normal. Good?
I suppose.
You suppose?
I guess.
So we have a lab that we're gonna do. It is called a GPE lab. We're gonna look at gravity and we're gonna look at elastic potential energy. So we will kind of start into that, I think tomorrow, this video, it's a little bit crazy, I'm not gonna lie.
Kind of.
If it's the one I'm thinking, oh no, it's not, it's a different one. This isn't crazy, this is the road rush. Gravitational and elastic potential energy.
Kind of.
No.
Kind of like this stuff.